So this is going to be a shorter but somewhat more advanced version of the transform talk that we had last time. So there's a couple of things that I wanted to give you additional insight to because they might be things that you will see when you're actually interacting with real data. So the plan here is to talk about long and wide data transformations. So often you will see data coming in one of these two forms, and I'll explain that. And I also want to talk about how to build multiple charts. So when we get to discussing small multiples, you'll often want to be able to have many charts being displayed side by side or on top of each other. So I will walk you through how that is done in an easy way through Altair. So we're going to use the same data set that we used in the last lab, specifically the movies data set. So why don't we load this up? And we have it, okay. Just as a reminder, what we have inside is movies sample 2, just so you can see. So we have the titles, US gross, worldwide gross, and then a bunch of other features, including major genre that we'll use often. So we have this data, and I want to distinguish between long versus wide. Before we get into how to transform and do all this stuff, I just want to say that our goal in this particular exercise is to generate a simple visualization like this. So this is a bar chart. We have movies at the bottom. These are movies selected in a certain way. I'll explain that in a second. But you can see a stacked bar chart which indicates both worldwide gross and US gross. So you see two different colors, the orange and the blue, to describe that. So this is going to be our goal. So before we go on, I just want to be clear about Altair and Vega Lite in terms of the way the system renders visualizations. A way to think about this is Altair and Vega Lite are very much driven on a row-based scheme. So every row will end up being represented by a mark. Okay, so when you're looking at this visualization, the thing that looks like a single solid bar is actually two bars, one on top of the other. So you have the blue bar and the orange bar. For example, for Duel in the Sun, the first one. So this is one mark over here, and this is another mark over there. Okay, so we have these two marks being represented for every movie. But Altair likes to think in terms of rows. So every row should be its own mark, ideally. Okay, that's the ideal way to represent this. So how does this work? If the data was in a form like this, we'd be okay. So imagine items are the movie names and the keys represent the US gross or the worldwide gross, and the value is how much money they made in each of these two environments. This representation is what is known as long form. So if the data looked like this long-form representation, Altair would make the stacked bar chart super easy. So this is just the way we would ask for a stacked bar chart. So the X would take the item, it would be the movie. The Y would take the value, so how much money it made would be represented there. And the color would simply be the key. So is it US or worldwide gross? So this would be a way of taking that simplified data set that you just saw and transforming it into a stacked bar chart. But what we have with a movies data set and what you will often see is something like this. So this is called a wide form data. So we have the items on each row. It sort of makes sense. Like this is a totally reasonable way to represent the data. So each movie would be on each row. And then a separate column for each of the keys that we care about. So US and worldwide gross would be separate columns. So if we had the data in this form, we can think about different options for visualizing it. So let me show you the way that you would do it without any sort of transformation and why that might not be the best idea in the world. So let's transform the data into this form, and I'm just going to grab a small subsection of it. So I just want to show you what it looks like. So I just want a few of the rows that we care about. So these are just 10 of the rows, and you can see I've pulled out the title, US gross and worldwide gross. So now I have the movies in this wide format. So let's consider the visualization that we want. So we can look at this visualization and think about maybe applying a layering approach. If we think of this entire thing as being composed of two bars, one is a bar that is blue sitting in the background representing the sum basically of worldwide and US gross, and then another bar sitting in front of that, the orange bar, representing the worldwide gross. So if we made two separate charts, that's one approach, one blue for sort of the background, which has the sum, and one orange for the foreground, which is just the worldwide gross, we get pretty close. So let's do that very quickly, and you'll see why it's a little bit of a hassle. So let's start by making actually we're going to make, it says US bar, but let's make the worldwide one first. It'll be a little bit easier. So make the worldwide gross bar chart. So let's make C1 equal to alt chart. We're going to use our movies wide data set. We're going to use a bar. We're going to make it orange because that's the color that we're using in the front. And then encode, and then we have to encode the two different things that we want. So X is going to be alt X title. It's a nominal variable, and then the Y, the height, is going to be the worldwide gross. Worldwide gross. It's quantitative, and then we can see what it looks like. So, okay, so pretty good. So we have our orange bar. Now we need to think about the blue bar, because the blue bar is the sum of these things. We don't have that data actually in the data set. So we need to calculate it. So this is already where you're starting to get some of the pain. So let's go back and copy this, because we're going to use this as a starting point. So, oops, Shift Enter, and then paste it over here. This is going to be the make the total bar chart. So this is going to be the blue part that sits behind. And we don't have a variable called total gross, but we're going to make something called gross sum, but we do need to calculate it. So how do we do that? We're going to use transform calculate. So transform calculate, and we need to specify that we have this thing called gross sum, and that's going to be the datum.us gross plus datum.worldwide gross. So for every row, calculate the sum, and then we're going to use that as the visualization. So this is going to be C2 before we get confused, and just so we can see what it looks like, we'll do this. Okay, so we have our blue bar chart. The numbers are a little bit different. It might look the same, but the numbers are actually the total. And so now we can layer them. So we can put C2 in the back and then C1 in the front, and we have something that looks approximately like what we wanted, but we have weird variable names because now it's gross sum instead of US sum. We also don't have the legend anymore, which is something that we might want. And so it's not really the best way to do this. So we can go keep tweaking this and changing all these titles and labels and whatnot, and maybe we'll get pretty close. But it turns out that there's easier ways of doing this. I'm going to show you two different ways of changing the wide format back into long format. And once we have that, it's really a simpler chart. We're going to do this in two ways, though. One is using pandas, and one is using Altair directly. So the way of doing this in pandas is using something called melt. So we're going to make a movies long. So this is going to hold our new representation. And we take our movies wide data set, and we use a command called melt. Melt will take in an argument that says, what do we want to keep as sort of the index column? So that's title. Where are we getting the variable names? Or where are we going to put the variable names? So we have two columns that we're going to be extracting from and putting into this column. So it's either going to be US gross or worldwide gross, but we need to give this new column a name. So it's going to be gross simply, and that will either have one of those two strings. And then we need to specify where we should put the numbers that currently exist in the cells. So we're going to say value name equals dollars. That's going to be the name of this new column that we create. And let's just look at what's inside. Movie sample 10. And voila, we have what we wanted. We have a different row for every combination of title and gross type. So we have two, you can see row 13 and row 3 are the same movie, but there's two different rows assigned to them, one to US gross and one to worldwide gross. So now once we have this representation, this movies long representation, it's really easy to pull out the bar charts. So alt chart movies long mark bar encode. So X equals alt X, and that's going to be the title. And Y is going to be our dollars. That's quantitative. And then the color, this will determine what colors the bars should be, is going to be defined by this column called gross, which is a nominal string, either US or worldwide. And we run this, and voila, we have the visualization that we wanted. Okay, so this is a very nice way, a simple way of transforming the data using pandas in this case to get this. Now, if you don't want to use pandas, and we've talked about reasons for not wanting to use pandas, like if we want to deploy this out on the web, you might go and find the way to do this in Altair. The way to do it in Altair is something called transform fold. So Alt.chart, actually, let me go back one, and we're going to copy this because we're just going to add the transformation right before. So we do this, and then we're going to add transform fold. So transform fold. Okay. Transform fold works much the same way as the melt did. We need to specify the columns, or sorry, the strings that we care about. So the different things that we want to make into new rows. We want to make US gross and worldwide gross, which are currently column names. Those are going to be placed into our new data set as rows. Okay, so we need to specify which columns are going to be transformed into rows. And then we need to specify where those things go. So we have this special operator called as underscore, and that tells us where to put the data. So the keys are going to go into a column called gross, and the values are going to go into a column called dollars. Okay, and with that, we can basically just run this. And oops, what did I mistype? Oh, sorry, movies wide. Starting with the wide representation. Oh, and this should be Y. Okay. And one last mistake. This should be like this. So it's a list. So US gross and worldwide gross. Okay, perfect. So now we have our bar chart, a stacked bar chart, using this basic transformation. So we went from the wide format. We specified through transform fold which of the columns we cared about to transform into rows. So US gross and worldwide gross are going to be the things that we essentially pivot on. And then we're going to put either one of these two strings into this new column called gross. And then whatever value existed in the original cell should be placed in this column called dollars. So one last thing, there might be situations where you need to go from the long form to the wide form for some reason. So there might be some representation that needs it. Unfortunately, that's pretty rare to want to do in Altair. So Altair does not have really an easy transformation to do that with. So I'll just show you very quickly how to do that using pandas. So if we have our long format again, so movies long sample, just to remind you what it looks like. Whoops, movies long. This is what it looked like. So we have all our different titles, and then we had a row for each, we had two rows for each, one for US gross and one for worldwide gross. Okay, so the transformation that we're going to use here is something called pivot. So movies long pivot. We need to specify what the index is, and that's title. And we need to specify what columns we care about, that's gross. And then the values that we want, that's dollars. So we're basically just indicating which columns to pivot back from. So the column that we care about to basically translate back into, the things that were, that's currently a column called gross will become separate columns. So each of the different types, either US or worldwide, will now become its own column, and the values into those cells is being pulled from the dollars column. So let's just see what, actually this will just print. So, okay, so, it's close to what we want, but this is a simple way to pivot back into the wide format from the long format if necessary. Okay, one last thing for this particular lab, we're going to talk about compound and faceted charts. So let's say our goal was something like this. So we have 4 different visualizations side by side here. You have Rotten Tomatoes rating versus US gross, IMDb rating versus US gross, Rotten Tomato rating versus worldwide gross in the bottom left, and IMDb versus worldwide gross. We're basically trying to compare in this grid these rating variables to the gross variables. Like maybe we had a hypothesis that there was some correlation between movies that cost more and were being more highly rated. You can see this a little bit in the visualization, but it's not a perfect fit. Anyway, how would you do this using what you already know? The way you might do it is starting to build each chart one at a time and then putting them together. So maybe you want to pause here and give this a try. This should be relatively easy given what you already know. So pause here and then I'll walk you through it. Okay, so the way we might do this, I'm just going to copy and paste because this is going to be pretty redundant. So C1 might be sort of our first chart. So this will be the thing in our corner, and we need 4 of these. So I'm just going to copy this 4 times, and we're just going to modify what's in the X and what's in the Y. So we have C1, C2, C3, C4, and we'll plot this. We'll go to the next cell so we just have a little bit of space. And now we can start to construct this grid. So at the top of the grid, we had C1 sitting next to C2, so it might look something like this. And then that part of the visualization might sit on top of C3 and C4. Okay, so we got the visualization we wanted in the end. It's not sort of the easiest way of doing it, but by building each visualization independently, we could also have written a function to iterate, but we were able to construct the simple kind of small multiples display. Turns out that there's an easier way to do this inside of Altair, and that's called a repeated chart. So the way a repeated chart works is this. You can basically... Well, let's just start with a simple definition of the chart that we're going to use. So alt chart movies, and then we're going to use a point and encode. And now we need to define the X and the Y. But what I'm going to do is when I define these, I'm going to just leave a placeholder. So I'm going to use something called alt repeat. And I'm going to specify that it's going to come from something called the column variable. Now, you don't need to know what this is yet, but basically it's going to be a placeholder for some data that's fed to it through some other way. Now, this is a quantitative variable, and then we also want to do the same thing for the Y, but the Y is going to get its values from something called the row. Okay. And again, quantitative. So, okay, so far so good. We need to specify how big we want each of these smaller charts to be. So I'm going to do it like this. So width equals 200, height equals 200. So consider this to be sort of the definition of the mini chart. This is the property of that mini chart. And now we use the special repeat command. So what repeat will do is take in a chart definition and then we'll do it multiple times. And each time it goes through this list that we'll create in a second, it will basically render one of these mini visualizations, replacing as it goes these variables, column and row. So what's our row? A row, remember, in our visualization, we had at the bottom basically US gross and worldwide gross. And our columns were going to be the Rotten Tomatoes rating and the IMDb rating. And we're going to run this. Oops. Oh, forgot this. Oh, and we also made X twice. So like that. Okay. Perfect. Okay. So this is a little bit cut off, but if you do it in your own lab notebook, you'll be able to see that you actually got to the right visualization. So actually, why don't I do this? So we'll call this combined. We'll run this. We'll go to the next cell. We'll just type combined in here. So hopefully you can see it a little better. Okay, great, perfect. So here's our small multiples display. So that was a easy way to use this repeated form to basically get what we want. All we had to do was specify what was in the columns and what was in the rows, US gross, worldwide gross, Rotten Tomatoes rating, IMDb rating, define what we wanted in the mini chart with a placeholder that would then get executed by this repeated command. All right, so here's another kind of simple example of a small multiple that is a pain to implement if you use sort of the standard Altair approach, but using some of the built-in features, specifically faceting, it becomes much easier. So our goal here is to generate a visualization that looks something like this. So we have, for each of the movie types, we only picked 4 movie types here: action, comedy, drama, and romantic comedy, and I want to know how many movies were released in which month. Okay, so I have this dot plot, which is essentially a time series, and you can see the release date, and you can see sort of points representing how many movies. So drama has lots of movies being released in December, and action has lots of movies being released in summer and June. All right, so we want to generate something like this. Before I start, maybe you want to try stopping here and building this. So using sort of what you already know, can you build this visualization? Okay, let me show you how to build just one of these cells. So we're going to make an action cell. So it's going to be Alt Chart Movies. We're going to do Transform Filter because we only want the action movies. So we want Alt Datum dot Major Genre to be action. So this will just give us action movies. We want point. We want to specify the color, so maybe light blue. And then we want to encode. So on the y-axis, so because we are essentially generating a histogram, we need to specify what we're binning by. We're binning by month because there are many different years and many different movies released on days of the month, and so we have to bin them somehow. Thankfully, Altair can do this for you using this month argument. So you can take month of release date, and that will look at all the release dates, which are full dates, month, day, year, and we'll just pull out the month from those. And this will be essentially our binning variable. So that is an ordinal thing. And then we're going to count how many movies are in each bin. Okay, so let's just plot this so you can see what it looks like. So we'll just do action and run it. Okay, that's not bad. So if we wanted to make the side-by-side version, we'd basically just copy this one at a time and then assign colors that were different and put them together at the end. So that's okay, we could do that. If we had lots of these, it might be difficult and we'd have to figure out which colors we wanted and then how to make a legend and so on. All right, so how do we do this? We're going to use something called faceted charts. So let me show you, before filtering, I'm just going to build this. So Alt Chart Movies, and then we're going to do mark point and encode, and then we're going to specify the definition of what our mini chart is going to look like. So X, just as before, it's the month of the release date, and that is ordinal, and we're going to specify that Y is the count. And now we're going to want, count. We're going to want a different color for every genre. So I haven't told you sort of how we're going to generate different genres, but I'm just going to do this. So color is major genre, and that's a nominal variable. We want to specify the size of each of these mini charts. So properties with, let's say, is, I don't know, 180. That'll make it small enough. And the height should also be 180. And then to the end of this, we're going to add something called facet. Okay, and facet will tell us which things we want to facet on. So in this case, we want to facet on the major genre. So we need to specify whether we want these things to sit in rows or columns, or I'll show you how to do both in a second. But let's say we want the faceting to happen by columns. So we're going to have bar charts next, or sorry, these scatter plots sitting one next to each other. So we'll do column equals major genre n, and we'll plot this, comma over here, release date. All right, so that's okay. We have too many movies, right? So we said we only wanted a few of them. So if you remember, the way we do that is using the transform filter, and I'm just going to copy and paste this, but I'll leave it up on the screen for a second. So we'll take this, we'll copy it over, transform filter. So transform filter, the specific filter I'm going to use this time is field one of predicate. The field that we want to filter on is major genre, and I either want it to be drama, comedy, action, or romantic comedy. And I will plot these, and now we get the visualization as intended. The right colors, the right legend, everything comes together very nicely. Okay, so one very brief last thing. So let's copy this, and we're going to move it to the next cell over here. So if you remember, when I didn't have this transform filter in, let's just get rid of it. This is kind of messy. Like, we don't want all the movies to just sit in one really long row. So is there a way of faceting so that it's actually a little bit easier to read? So can we get kind of something that looks a little more like a grid? So the answer to that is yes. Facet will take 3 different kinds of directions on which to facet. So it could be either it could be column, or it could be row, and then it would look something like this. It's hard to scroll in this, but you can basically imagine that it's one sitting on top of the other. The other way to do it is something called facet. So we had column, we had row, and I'm going to give you this notion called facet. And a facet will take an additional argument which specifies the maximum number of things that we want, in this case on every column. So in this case, we'll say we only want 5 visualizations, 5 of these small visualizations on each column, and we will plot it. It's a little bit hard to see. Let me escape out of this. Okay, so you can see down here basically this representation where we have 5 different things, 5 on each row, and then we have 2 missing at the end, but that's the way it goes. If we wanted to maybe make this a little nicer and easier to read, maybe we'll do this. Okay, so that's maybe a little bit more user-friendly, like we can put it on one screen. So this was a very quick and basic introduction to using faceting to get small multiples. We're going to need small multiples for some of the data sets that we'll see later in the semester, or you might need for your own use. And the other thing that we talked about, if you remember, is the wide versus long transformations and why it's easier to work in that long format view. So with that, thank you for listening. Hopefully this is useful for you. Thanks.